Today I will be going over how blood glucose levels are regulated in our body and how insulin is used to take up glucose. I will begin with a general overview of how this process occurs. First, when you are starving, you have low blood glucose. This causes a signal to the pancreatic alpha cells to then stimulate the liver to release glucose into the blood via gluconeogenesis, thus normalizing blood glucose levels. Now we will be going over how high blood glucose levels are regulated. After eating a meal, blood glucose levels rise. This then stimulates the pancreatic beta cells to release insulin. Insulin then stimulates fat cells and muscle cells to uptake glucose from the bloodstream. This step normalizes blood glucose levels. Now I will be going more in depth on how insulin plays a key role in the absorption of blood glucose. First, glucose gets transported into the pancreatic beta cells via GLUT2 transporters. This transport of glucose into the pancreatic beta cells causes an increase in glycolysis. An increase in glycolysis leads to high levels of ATP, which cause potassium channels to close. This causes the cell to depolarize, and as a result, calcium channels open, leading to a high concentration of calcium ions, which cause insulin vesicles to fuse to the membrane and release insulin. Insulin then binds to the insulin receptor, which causes a phosphorylation of IRS1. IRS1 further phosphorylates PI3K, which then phosphorylates PIP2 to PIP3. PIP3 gets recruited to the membrane to phosphorylate PKB. PKB is now in its activated form and undergoes many pathways. It first inactivates GSK3. The inactivation of GSK3 causes an activation in glycogen synthetase. This then leads to an increase in glycogen synthesis. PKB also activates GLUT4 translation. In a separate pathway, PDK1 and PDK2 are also activated.